By request, this is the solution for 7.1, number 64, out of the 8th edition of the Stewart text. This is a rotation about the x-axis of y equals e to the x, or the region bounded by y equals e to the x equals 0, and y equals 3. I'm going to take a moment, pause the video, and draw that region. Okay, so what you see here are the curves y equals 3, and I'll just erase what we're not concerned with, and then the curve y equals e to the x, and again, I'm going to erase the part we're not concerned with, because what we want to do is we want to rotate the region bounded by y equals e to the x equals 0, and y equals 3, and we're going to rotate that about the x-axis here. So let me go ahead and rotate that around there. And you should get something like, and I'm going to try to draw this in real quick, something like that. And so they ask us to do it in the problem using shells, cylindrical shells, which means that we are going to do horizontal slices. If you try to do vertical slices here, it'll rotate around and become washers. So we need to do the shell method here. And I'm just going to remove a lot of my drawing because it's in my way, just to get a cleaner looking slate here. So I'm going to draw in a typical slice. Here's a typical slice for my shell method. You can see this is a dy, delta y. And remember, when you rotate that around and you get some type of shell, right? It has a thickness to it. And you're going to rotate it around by a circumference. So the volume of that ith slice, if you will, has a circumference of 2 pi r. It has a height, which I will call this height, h sub I. And it has a thickness, which we call delta y. The r sub I is the distance from the central axis of rotation. Okay? So all my pieces are labeled beautifully. So this volume is going to be 2 pi. I can see that radial distance is just the current y value. The height, this distance here, is the current x value. And then we have delta y. Now let's see. I need this to be all in terms of y's here. And so here's my relationship between y and x. The natural log of y is equal to x. So this volume of the ith slice is 2 pi y sub I, natural log of y sub I, and then delta y. So therefore, we are going to find the true volume by, and I'll factor out the 2 pi here, integrating from a height of, let's see, it actually starts at a height of 1, ends at a height of 3. So starting at a height of 1, going to a height of 3 of y, natural log of y, dy. And this is one of those cases, you always, I mentioned it in class, you have your choice of how to think about these things. You either think about something that you want to integrate or something you want to differentiate. If you're thinking in terms of what you want to differentiate, you want the thing you differentiate to change forms. That's generally what we'd like to do. So I am going to choose the natural log of y to differentiate, and I'm going to choose the y dy to integrate. So in my my by parts method here, because that's the only way to do this, I'm going to let u be the natural log of y, and the dv to be y dy. The derivative, or the differential of u, is going to be 1 over y dy. And the antiderivative of v is going to be y squared over 2. And now recall that by parts gives you, if you are starting with the integral of v du, it's equal to, I think I write it differently. U dv, it's equal to uv minus the integral of v du. Okay, so in this case, we do have u. We have these two pieces right here, which are dv. So the integral of that u dv is going to equal 2 pi times the quantity uv, which we have these listed right here. It's the natural log of y times y squared over 2. And we're going to evaluate those from 1 to 3 minus the integral from 1 to 3 of v du. V du is going to be y squared over 2 times du is 1 over y dy. It's actually not a bad integral. This is going to equal 2 pi. Natural log of 3 times 9 halves minus the natural log of 1, which is just 0. So I don't have to worry about that. And then, let's see, minus the integral from 1 to 3 of 1/2 y dy. And let's see here. This is going to be 2 pi times the quantity 9 halves, natural log of 3, minus 1/2 y squared over 2 being evaluated from 1 to 3. So this is 2 pi. Actually, all these terms have a half in them, so I'm going to factor out a half. So I just get 9 natural log of 3 here, minus, we'll have a y squared over 2, which is 9 halves, and then plus, because the sign flips, we'll have a y squared over 2, which is a 1/2. Now I can clean this up. So we pi times the quantity, 9 natural log of 3, minus 9 halves plus 1/2 is negative 8 halves, which is a negative 4. And there you have it. That is the volume if we were to rotate that region about the x-axis. And you could only do that using by parts.